Air conditioning California homes account for about 14% of all the peak electrical energy that we use. And since we build about 130,000 new homes a year, that's a lot of energy. A big part of the energy that homes use takes place from their heating and cooling systems. In fact, about 25 to 30 cents out of every dollar that we spend on heating and cooling is lost through leaks in the ductwork. Joining me today is Scott Johnson, who's a home energy rater, and you diagnose and you certify homes to make sure that they meet the code. Now, you've inspected this home, Scott. What did you find?
I found several problems with this home, Steve. Most of them are airflow problems. We've also found a few leakage points. This one right here in front of us, see the way this duct comes and it makes this real tight bend here? Well, it's restricting the air inside of there. It's never going to get downstairs where they need it for the comfort of the occupants. And it's also going to infringe on the capacity and efficiency of the equipment itself too.
How much would a kink in a duct like this reduce the airflow downstairs?
30 to 60% easy, Steve. Could be more.
That's pretty significant.
Yeah.
What other things did you find here?
Well, I found other restrictions. There's a restricted return duct, and there's a problem with a shaft with many ducts running on the side of it.
They get all compressed.
Yeah, right? the shaft is just not big enough to accommodate the ducts.
Any other problems you found in this house?
The equipment leaks. The equipment's leaking air. And there's actually this one is leaking air too also. We'll see in our smoke test.
Now, in general, the types of homes that you look at, what are the top 10 things that you find?
Sheet metal joints leaking, where you hook flex ducts to sheet metal, and all the attachments at the equipment itself typically are the largest leakage culprits.
What about supports, things of that nature?
Oh yeah, all the time. The installers sometimes miss supports, and the ducts are sagging with age and gravity. And you end up with worse and worse airflow as the house ages.
Now, the code requires that they're supported, what, about every 4 feet?
Every 4 feet. That's correct, Steve.
What are the requirements around sealing the ducts? The code requires that there can be no more than, what, 6% of fan flow?
Correct.
So that means that if I've got a 1200 CFM system, I can only leak 72 CFM. That doesn't sound like much.
No, it's not, but actually it's easy to meet that. It really is easy to meet that target.
Now, you have set up some equipment, a duct blaster, where we can actually do a duct blast test on this home. Let's go try it.
Set up. All right.
So, Scott, this is what you call a rough-in duct blast test. Tell me about the machine and the test.
Okay, Steve. Yeah, this is a simple test. What we do is we seal off all the outlets where the air is coming out of the house into the house.
That's what these foam blocks are for.
For the supply boots, and we block off the return ducts too. And this fan here forces air into the duct system, okay, under a given pressure, which is 25 pascals for this test.
And that's about the same as the system operates, so you're not like blowing the ducts up.
Oh no,
it's a very minor amount of pressure.
Small pressure, doesn't injure the system at all. And when we force air into the system, the air going in is direct proportion. If you added up all the leaks added up together is the air that's coming inside the fan.
So it's very easy to diagnose not only where the leaks are at, but how much they are.
Absolutely.
Well, let's fire up the machine and see
all
how
right.
we do. Now, this device here is what? It's called a manometer?
Yeah, it's a digital manometer, Steve. It's a very accurate pressure gauge. It's just simply measuring pressure difference from one point to another. And right now, I'm testing the duct to a reference pressure of 25 pascals. And once we achieve that pressure, then we switch it over to a different mode, and it sees how much leakage it is. And right now we'll go ahead and get that number, and it's 66 cubic feet per minute, and our maximum amount is 120, so we're just a little bit over half of what the test can have.
That's pretty good.
Absolutely, great system.
Now, where does most of the leakage usually occur?
Most of the leakage usually occurs, and this system is no different. It occurs at the piece of equipment itself.
So, now, you have to be certified to basically do these tests
Absolutely.
in order to meet the code. Now, tell me about a HERS certified rater. What does that mean?
Well, a HERS certified provider, which in California it's CHEERS, California Home Energy Efficiency Rating System, they train, certify, and do QA on raters. So not just anybody can go out and become a rater. And you go through the training process, the testing procedures, and then they follow you up out in the field to make sure you indeed know what you're doing.
Yeah, well, I understand that you have a smoke generator here. Now, obviously, you always test just with air, but for demonstration purposes, you can help us find where the leaks are in this system.
Absolutely, yeah. We can find exactly where they are by introducing this smoke into the stream of air. And we can visually find where the leaks are. So
Well, I can see quite a bit is coming through the return side, which is pretty important because that return air duct's up in the attic.
Yeah.
That means it could be sucking in 140-degree attic air into your air handler unit, which is going to really reduce the efficiency.
absolutely, lose all our capacity to the attic instead of the inside like we want it.
Also, there's quite a bit leaking out of the unit itself.
The furnace.
Now, there's not much the builder can do about that.
No, because the HVAC contractor just has spent some additional attention in sealing up the equipment how it comes from the factory.
Where else do you find leaks?
All over throughout the system. It just depends on if the guys made a mistake in installing it, or they maybe not need a little bit of training on how to put their components together.
Well, thank you, Scott. Appreciate you being with us today.